In question 2, in the first question, we have to use De Moivre's theorem. De Moivre's theorem basically says that if you can write a complex number in this form, r cos theta plus I sin theta, z to the power n will be r to the power n times cos n theta plus I sin n theta. Now this expression on the top can be represented as 1 cos theta plus I sin theta to the power 4. This is just saying it's z to the power 4. If this expression inside is z, this is z to the power 4. Using De Moivre's theorem, I can write it as cos 4 theta plus I sin 4 theta. And we have 1 to the power 4 in front, but that doesn't change anything. So the numerator can be written as cos 20 pi by 12 plus I sin 20 pi by 12. The 20 comes here from multiplying 4 over here. So this is how we work with the numerator, and we can do the same with the denominator as well. We just have to make sure that this minus sign is changed. So I can do that by using this identity over here. So sine of theta, or sine of minus theta, is equal to minus sine theta. So I'll use the opposite one over here. So sine minus sine theta is sine minus theta, whereas cos theta and cos minus theta are the same thing. So this is cos minus pi by 3 minus I sine minus pi by 3. Basically, if I add a minus over here inside the sign, I'll also add a minus here. So the two minuses over here combines to make a plus. So I get plus I sine minus pi by 3. And then we raise this to the power of 3. So we get this expression. So now we get cos 3 into minus pi by 3 plus I sine 3 into minus pi by 3. I just get cos minus pi plus I sine minus pi. Since we know the exact value of cos minus pi and sine minus pi, we can just calculate this. Cos minus pi is minus 1, whereas sine minus pi is 0. So we have I times 0. This is just minus 1. So the whole expression can be written like this: cos 20 by 12 pi plus I sine 20 by 12 pi divided by minus 1. So over here we get minus cos 20 by 12 pi minus I sine 20 by 12 pi. Now I want to convert this into cos 2 pi by 3. So if I notice over here, we have this rule. Cos theta minus pi is the same as minus cos theta. So this can be written as cos 20 by 12 pi minus pi. You have a minus here and a minus from this, so this becomes a plus. And for sine 20 by 20 by 12, we can do the same thing. The same identity holds. So sine theta minus pi is the same as minus sine theta. So I can do the same for this. I get plus I sine 20 by 12 pi minus pi. Basically I get a minus from before and a new minus. This becomes a plus. So finally I get cos 2 pi by 3 plus I sine 2 pi by 3. Another way to have done this problem is, instead of calculating this minus 1, I could have kept it in this form. I'll do this down below. This is the other way. Instead of this, you can do this. So now we'll divide complex numbers in their polar form, and if you do this, this 1 and 1, these are the magnitudes. So r cos theta plus I sine theta. I have r1 cos theta plus I sine theta divided by r2 cos x plus I sine x, something else. If I do this, the result would be r1 by r2 times cos theta minus x plus I sine theta minus x. So this would have been cos 20 by 12 pi plus pi plus I sine 20 by 12 pi plus pi. This would have been cos 8 pi by 3 plus I sine 8 pi by 3. And now we know that cos 2 pi by 3 is equal to cos 8 pi by 3, and sine 2 pi by 3 is equal to sine 8 pi by 3. And then you could have written it in this form.
Now for part B, we have to draw a Argand diagram, and on this we have to shade the region bounded by these two curves. Now for the first curve, anything in the form of z1, z minus z1 equals to r is a circle with center z1 and radius r. Now in this case, z1 is this value over here. If I want to find the center of the circle, I can just convert this into a plus bi, this form. So z1 is cos 2 pi by 3, which is minus half, and then we have plus I sine 2 pi by 3. Sine 2 pi by 3 is root 3 by 2. So this will be a circle with center at half, minus half, comma root 3 by 2. And this one, the blue one, anything in the form of the argument of z minus z1 equals to theta is a half line. So the line starts at, it's basically a ray. So it has a starting point but has no ending point, it's infinite on the other side. So the starting point is z1, and we know which angle it's pointing at from theta. So if the theta is the angle from the positive x-axis, so this is the curve, and this arrow just means that this goes on forever. Now we'll draw the circle at first. So we have an Argand diagram, the imaginary and real axis. we know that the center is at -12 in the real axis and √3/2 in the imaginary axis. Now the circle could be like this, it could also be like this, and it could also be like this. So we want to know if it cuts the origin is here or here. So to do that, I know the center. I'll find the distance from the center to the origin. So this distance over here is square root of -12 square plus √3/2 square. This value will be 1, which is equal to the radius. Now if the distance is equal to radius, then the circle cuts the origin. If this distance is less than the radius, the origin is inside the circle. And if distance is greater than radius, the origin is outside the circle. So in this case, since it's equal to the radius, the circle will go through the origin. If the distance was less than radius, then this would be the case, and if the distance was greater, it would be something like this. So the circle would look like this. Now for the half line. The half line begins from Z1 as well, and it's between two angles. The first one is 0, so this angle over here, which is 0 degrees from the positive x-axis, positive real axis, and this angle over here is 3π/4, which is around 135 degrees, so an obtuse angle like this, and this angle over here would be 3π/4. So we can draw this. This is one of the line and this is the other. This angle over here is 3π/4. Now the shaded areas would be less than the circle, so inside the circle. If it was greater, then it would be outside the circle. So for the circle, the red part is the shaded area, and for the half line, you want the angle to be between 0 and 3π/4. So you can be anywhere over here. Your angle just needs to be between 0 and 3π/4. Other than that, you can go anywhere. So this part is the shaded area for the half line. So the common shaded area would be this part over here. And that's it for part B. Now for part C, we have any complex number inside the shaded area, and we want to find the smallest possible positive value of the argument. So the argument is the angle from the origin. So it's in this direction, anti-clockwise from the real axis. So the smallest angle, if you noticed, would be when it's here. So if I change the color, so this point will have the smallest argument. So if I draw a line like this theta will be the argument. So moving to part C. Now to find this theta, all I need is this height and this base. After that I can just use tan theta equals to height by base. Since I'm using this as theta, I'll just take this as opposite and this as adjacent. Tan theta is opposite by adjacent. Now the opposite, we know that it's root 3 by 2. And for the adjacent, I know that the radius of the circle is 1. So this distance over here from the center is 1. And I also know that the center is at minus half. So this point over here is minus half plus 1, which is half. So the adjacent is equal to half. Therefore, tan theta will be equal to the opposite, which is root 3 by 2, divided by the adjacent, which is half. So tan theta is equal to root 3, theta equals to tan inverse root 3. So theta will be equal to pi by 3.